Let's start.
All right. Hi, everyone. Can everyone hear me well? Let's let's just get some confirmations from the chat. Can everyone hear me well? All right. That's good. Thank you so much. So this is my first time speaking here at GDG Allen. So it's good to be here. I joined in on the last code lab and it looks good. Thank you so much, Gabriel. Okay. So moving on, what I would like to do over the next few minutes is to demonstrate and explain to us how easy it is to build multi-agent systems. So for a bit of context, we would be using this code lab, and I'm just going to share it right in the chat so everyone has access to it. And it's a follow-through code lab, completely hands-on, completely comprehensive. We would follow through it and we will get to the end goal. So the code lab has two options. The first option is you can decide to run it locally on your environment with Python installed using the G-Cloud CLI. That's the first option. And the second option is you can run it right in your browser. So we would we would open up Cloud Console, and then using the Cloud Shell and the workspace editor, we can do everything we need to do. So I will be going with the second option because I don't want to assume everybody has G-Cloud installed and Python installed, so we don't have to mess up our environment. So let's just use the browser and solve this particular code lab. All right, so moving on, what we're going to build, like I said already, is a distributed multi-agent system. And when we say distributed, it's not a very big word. It's distributed in the sense that we have separations of concerns at an agentic level. So we have an agent that is responsible for one function and communicates with another agent responsible for another function. And we have these autonomous agents all working together to achieve a common goal. So that's what we're going to build. And the end results, it's looking something like this. So typically you'd have your front end that the users just interact with, which these days is just an input field for a prompt. And then you have four agents that will be handling everything. We have the orchestrator. The orchestrator agent is going to be the agent that controls the other agents. Think of it like the master agent. And then you have the researcher. The researcher is that one that will go out to the internet to gather resources, that checks his knowledge bank to gather the resources we need. Then we have a judge that will determine if the resources the researcher has gathered suits the requirements. So the orchestrator carries ensures the researcher and the judge are constantly syncing and are agreed on the same goals. And when they've decided on the perfect content, the orchestrator hands it over to the writer agent that then creates the course. So what we're going to be building is a very simple course builder. And you could tell it give it a simple course like how to make cupcakes. And then we'd have a researcher that would go and gather all the necessary information. You'd have the judge that would verify the information, and then the writer that would create the course itself. And we're going to do all of that in few clicks. We'd write some Python. Most of the code is already pre-written, so we'll just be cloning, making a little changes, copying and pasting, and then we'll run some commands in the terminal to get this. All right, so let's carry on. So I've talked about the agents. I've talked about the agents we're building and the goal we're trying to create. And there's something I want to explain further before I move on to setting up. I want to explain the concept of loops. Now, a loop is, regular computer science term. A loop is an iteration, a constant iteration with defined steps, and you're doing them over and over again. And it's something that has been in existence, right from time before the agentic era. It's in every Turing complete programming language. So JavaScript, TypeScript, Golang, whatever, they have them. But even before programming languages, the concept of a loop has always been in existence in hardwares. It's the concept of a control loop where you have some system that is constantly working round the clock, ensuring everything works well. If something is bad, it raises an alarm. If something can be fixed, it fixes it. So the concept of a loop is something that has been existing from a very long time. And it is that same concept we are bringing here into working with agents. So while working with agents, we're constantly going to have a loop. And this loop is what is going to be the execution pattern for cooperating with agents. So you have a very simple, you can think of these three, the orchestrator, researcher, and judge, as a loop. You have the data goes from the orchestrator to the researcher. The researcher passes some data back here to the orchestrator. The orchestrator asks the judge if the work is correct. If the judge says the work is correct, not correct, it goes back to the orchestrator. The orchestrator does the same thing again, and it keeps performing this loop of data transfer up until it achieves the particular goal of getting the content it needs. And if you want to do that in something like ADK, which we'll be using, ADK has a concept called a kind of agent we call loop agent. Now, what loop agent does is it's a wrapper. It's a wrapper for this loop. But what it does is it runs agents inside that loop. So by specifying the requirements, specifying what you want to achieve at the entry point, and then you specify the agents responsible for each of these things, you can use ADK to easily coordinate agents in a loop until you achieve your goal. And that's the loop agent. And the second kind of agent we'll talk about is sequential agent. So the sequential agent is the very straightforward one. But we have data here. When you're done with this work here, you move to this work here. There's no cycle. We move from point A to point B, and we don't move back to point A. That's a sequential agent. So by combining these two, we would be able to build a loop agent that organizes three agents together, and then a sequential agent that combines those three with the writer agent. So we'll be combining these concepts together to build, a content creation course. All right, so let's move on. So to set up, I see we have already claimed cloud credits. So I'm going to start with, setting up showing how we can do everything from the ground up. So the first step is to create, you want to go to Google Cloud Console, and that's where we're going to do everything. Like I said earlier on, we're not going to work locally. So everybody with a laptop right now can do exactly as I'm doing with the codelab, and you'd work on it. So I see a question, if an agent is stuck in a process loop. Yes, typically you'd always pass a timeout. You would add timeout, because if you don't add a timeout, the agents will just keep going and going, and then tokens keep getting burnt and burnt. So there has to actually be a breaking point at some point. So it will be, you have to include a breaking point. We would show all of that in this code lab. Okay, so moving on. So we are on the Google Cloud Console, very intuitive, very easy to use. And I'm just going to open up Cloud Shell, which is the first step. You want to open up Cloud Shell and activate Cloud Shell. Then the next thing you want to do is you want to set up the starter application. So the starter application, there is already a GitHub project that has been created, and it has a starter pack for you. So you can just clone this and clone all three commands, which will cd into your home directory. And if you're working in Cloud Shell, this is going to work in your home directory. If you're not working in Cloud Shell, you can edit this to the directory you want to work in, right? But I'm working in Cloud Shell, so I'll copy all of this. And I'm going to clear my terminal so I can have some free space. And of course, you want to do your regular checks. You want to make sure you have your project selected in your terminal. You want to make sure the right account is selected. That's my email, and this is my project ID of choice. So I'm going to paste it. No, sorry. I'm going to copy again, and then I'm going to paste it. So all three commands. So you can see it got cloned into the right repository. And if I decide to do LSL, you would see the project. I'm inside, the Roadshow Lab 1 starter, which is the same repository that we just cloned, right? Yeah, so that's pretty much the first step. Then the next thing you want to do is you want to enable APIs. So some specific APIs are required. We're going to deploy to Cloud Run, which is important. We're going to use artifact registry, which is where the images of our applications will be stored. We're going to use Cloud Build because Cloud Build is how we're going to build the app before we deploy. You're going to use AI Platform. AI Platform gives you the access to Gemini using Vertex AI. That's what we require to use with ADK. And then we have Compute because you need computational services from Google Cloud. So Compute to probably make sure no other thing, that Cloud Run doesn't get broken at any point because all APIs will be enabled for Compute. Yeah, you can work on your local dev. The codelab has instructions that you can follow locally, right? I did the first iteration locally as well, and I did one on Cloud Shell. So you can do both. I confirm that both of them work locally. So you can follow through in anyone. Okay, so let's carry on. So the next thing you want to do is, I pasted the next commands to enable all these APIs. And it might take a while depending on your project. I have already enabled these things before, so it didn't take a while for me. But if you haven't enabled them before, it might take a while. It might require some authorization. And if you just hit yes, everything gets provided as you need to. All right. So the next step is to install dependencies. We're still in the same folder, the same directory. You copy this, and we're using UV. We're not using pip. The codelab author went with UV, and luckily for us, UV comes in Cloud Shell by default. So if you type UV version, you have UV in Cloud Shell by default. Let me just clear my tab and paste again. So you have UV sync. UV sync is going to ensure UV is a package manager for Python primarily, right? I think it was provided by Mastral, if I remember correctly. But UV, okay, can I zoom in? Let me see. Let me zoom in a little bit. Is it better now? Let me confirm from Pablo if it's better now. Yeah, better. Okay, thank you. All right, so UV is a package manager. In the JavaScript world, for example, there are several options. There is NPM, there's yarn, there's PNPM. In the Python world, we have pip for downloading dependencies, and most people use pip. I use pip for the most part. But there's also UV, and UV comes with a log file. UV comes with UV promises to be faster than pip and whatnot. And I don't know about that, but you could decide to use pip, right? But the project doesn't use pip. There's no requirements.txt file. There is a uv.log file. So the uv.log file shows you the content, the dependencies that we need, and the specific version. So UV is what you need to use here. So I ran that and it installed a couple of libraries for us. So we're done with that. So the next thing you want to do is you want to set up your environment variables. So setting up environment variables is quite simple. The first thing you want to select, you want to add is we're just putting a .env there, and we're going to specify our cloud project, the cloud location. We're using global because we're deploying. It's just Cloud Run we're deploying, and we're specifying it to global, so it's not a problem. And then we have Gen AI, use Vertex AI is true. This is a particular reason why we had to enable this, because it depends on this. For you to use Vertex AI true in code, it means you have to specify, you have to enable Vertex AI here. Right. So thank you, Gabriel. Yes. True. Astra was bought by OpenAI. All right, so I'm going to copy this, and as usual, it's the cycle of copy and paste, very safe and very simple to do. So all of that has been done. This will create a .env file for us. If I decide to cut it, you can see the .env file was created. It's just your project ID, global, and enabling Vertex AI. And that's the second step. What you also want to do now is you want to make sure these are added as your environment variables in your terminal. So you just source the env file. So sourcing it, source.env solves that problem. And if you do that, you can see that if you search through, you'd probably see all the variables that we just said. Yeah, so that's sorted. And that's this step. So we're done with the setup step. Very simple to do. We're moving on to the first agent. So the first agent is the researcher agent. And the researcher agent is a quick question we typically want to ask is, and it's a very valid question, is why are we not using one model to do everything? And the truth of the matter is the larger the amount of tasks your agent does, the harder it is to evaluate and debug. It's similarly the same way you typically break your code into smaller functions instead of putting all of the business logic in one function. The smaller the responsibility, the easier it is to maintain. So we could as well, instead of using one agent. All right. Okay, so let's carry on. So the researcher agent is doing that. So the researcher agent job is just to evaluate and gather research and do all the checks, gather research from the internet, and that's his primary job. He reaches out to the internet and gathers research. That's all. Uh, so yeah, let's create that. So the first thing you want to do is we want to set up Cloud Shell Workspace. You want to open up the repository, the projects in Cloud Shell Workspace. Now, a bit of an explainer. Cloud Shell Workspace is also known as the web editor, and it's or Cloud Shell editor, and it's just basically a VS Code instance running in the web and attached to your GCP account. So rather than having to, so we could use VS Code here, and everything begins. Everything could easily feel like everything could feel like as if we're working locally, because it's at the end of the day, it's just VS Code running in the web. Yeah. So I see a bit of discussion on Astral and UV going on in the chat. That's nice. So the editor takes a while, many a times, but after the first load, it becomes easy to load multiple times. So that's the first agent. So let's just look at what we're about to do. So it's basically an ADK agent, right? It's Python, the ADK agent for ADK SDK for Python. And this is a simple agent we're working on. We give it a name. We specify the model. The model is a variable up in the code. and we give it a description, and you can see the description. It gathers information on a topic using Google search. And the instructions are straightforward. Expert researcher, you give it a persona. Your goal is to find comprehensive and accurate information on the user's topic. Quick instructions on what to do. Summarize your findings clearly, giving it more instructions. If you receive feedback that your research is insufficient, use the feedback to refine your next search. Right. So this solves, prompting at the end of the day is really your guide into bringing out very intelligent systems. So, and this instruction is very straightforward, very concise, and it does not beat around the bush. So the model would very glad to have such a precise prompt, so to say. So that being said, let's add that. So what we'll do is we're going to open up the agents, the researcher and agents.py. So the same project we're working on, which is this one. I have so many projects in my cloud editor, and it's because I've worked on several projects on my Google Shell. But this particular one, the one you just cloned, is called PRAI Roadshow Lab 1 Starter. That exact one. So while we wait for that to open up, you have your agents, you have the researcher, and you have the agent.py. Now the agent.py already defines some things. It imports the Google ADK agent. It specifies the model to be Gemini 3 Flash Preview, right? And then what you want to do is you just want to copy all of this, and we're going to paste it here like any other code base. And that's it. We've worked on our researcher agents. The researcher agents is done, and we can move on from there. The next part is, so when using, one thing to note, when using Gemini 3, the search tool is automatically available. So if you were working with 2.5, for example, you'd need to import the tool here. You need to import the Google search tool, right? And then you'd have to embed it here as a tool, and then you put Google search here. But with Gemini 3, we don't need any of that, right? Because Gemini 3 is smart enough. It has improved. It's an improvement on Gemini 2.5, and it knows the tools it needs to use. Right. So moving on, and the disclaimer is here, so you can always, do that. So the next one is the judge agent. So going back, the judge is the one who, so the researcher gathers the information, the judge gives the feedback to see if the research work is sufficient or if it's good enough for the goal we want to achieve. And that's what the researcher does. Let's see if I have more follow-ups in the chat. Yeah. All right. So, okay, I'm assuming everyone is following through there. Okay. So I see the credits are working now. That's a good one. Okay, so let's move on. So we're going to open up the agents/judge/agents.py. And what that does is that's the agent file for the judge agents. So we're going to simply copy all of this as well. Going to our workspace editor, judge agents.py, and we're using the same Gemini 3, and we're going to paste everything. Now here's the instruction. It evaluates the research findings for completeness and accuracy. You are a strict editor. Evaluate the research findings against the user's original request. If the findings are missing key info, return status of fail. If they are comprehensive, return status of pass. Is there a way to influence the judge's approval? Like, do we set it to review things like, yeah, it's all about adding more prompts. You could decide to tell it to, review it 3 times in the prompt, or you could also go, the LoopAgent way this time, but we won't do that here. But you could have the LoopAgent basically run the loop on the judge 3 times, right? Till you get a sufficient answer. So there are several ways to go about it, but yes, you can reiterate on the response multiple times. And another field you want to add is you want to disallow delegation, right? You don't want to allow the agent to transfer authority to other agents. What you want it to do is to just basically output a very simple response, either fail or pass. Those are the two things you want the agents to produce. And then we have a judge feedback, which is an output schema. So output schema just gives the agent, this is the structured output I want you to provide my response in. And then it gives a status of pass or fail, which the agent knows to read. And then it has the feedback, which the agent can add to describe why they said pass or fail, right? And you can see we use Pydantic a lot. For those of us who don't write Python, Pydantic, think of it as a library for schemas, basically. So when you want to transfer structured outputs, and it's not just for ADK, you use it in Fast API, use it for applications generally in Python. Anything that has to do with a schema and you want to be able to represent data in a structured way, Pydantic is the de facto standard for the Python community. So we have that. And of course, we specify the model as well, Gemini 3, Flash Preview. And this class is just a schema of status and feedback. And that's it for the judge agents. The judge agents is all good and ready to go. This place just talks about, I talked about delegation. So this is just a disclaimer explaining why we have that delegation there. So the next thing you want to do is, let's see how we can test in isolation. So you can actually test your application in isolation, right? You can test the research agent, you can test the judge agent, so we can see if they work individually. This also highlights the pros of using multi-agents. Because if you were to test something like this right now, if you had used just one agent, it means the one agent to do the searching and the judging immediately. But right now, even though we've gone a long way, we can still test things individually, which is, one of the advantages of using multi-agents. So let's run it. The first command we run to test our agents. So we're still in the Cloud Shell. We can, let me see. My project is not set, so let me just, I'm coming. Sorry. You have config set projects, or what I'll do is, so I don't have to switch multiple times, I'll keep the terminal here, the editor here, and I would maintain my shell here. So I'd have shell here, reconnect, and then I'll have my editor here. So let me just reconnect here as well, but I'll close that. So that way I get to manage both environments at the same time. Give me a minute. Let me pop this up here. Right. And then here as well, I'm going to close this so I can run this, at the same time. So while that is running, I have I'm in the roadshow. I'm going to just source the .env again. So I have my .env all set up here as well. While this is loading, I'm just going to test out other things. So what we want to do is let's test the researcher first. And this is the command to test out the researcher. Is ADK run the agent / researcher, which is just ADK's command for running a researcher. Okay, so I've run the command. So let's just give it some time. Yeah, and the user, so you could just type in a random thing. So let's give it find the population of Tokyo in 2020. So a simple one, which is this. So we paste that in the chat. and it goes to do a Google research, and then it gives us responses. According to the data from this was the population of Tokyo, and we have that. So we know the researcher works. We don't have to do more and more prompts, but we can see it works. We can close this to just cancel that process. And then we can, if you get an error, it's because you did not, your .env was probably cleared away. So you could probably just run these commands again, or you could source your .env to go back to where you were, right? Okay. User not found. If you get a user not found, it's probably because your account is not set. So you want to do something like gcloud config. You want to get account. You should see your email here. If you don't see your email here, what you can do is gcloud config, set account, and then you put in your email here. So when you do that, you should be able to authenticate. So as soon as you do that, you can now run GitHub config. You already have your project set up, else you wouldn't have gotten this error. So if 403 means the project is recognized, but you don't have access to it because it doesn't know who you are yet. So once you run the command I just showed, you should have access to, you should be able to run the agents properly. So let's test our judge. So to test the judge, I'm going to copy again and run the same commands. And this is going to spin up the judge. Okay. So I'm back to I'm keeping my editor here while we have the code here. So let's see. So topic, Tokyo, findings, Tokyo is a city. So let's just simulate some inputs to it. Right. And then what we expect from the judge, if everything went well, we expect the judge to give just one response, either a pass or a fail. And then it now describes the reason for his pass or fail. And if everything being correct, you see here, it's a JSON of status. Let me see if I can zoom in to have things better. Yes. You can see it's a JSON of status of fail and feedback. The findings are extremely minimal and they lack depth. So even if, all we had is Tokyo and findings Tokyo is a city, the actual goal of the judge is meant to determine if the response actually matches all the context you need to say you've answered a given topic. So saying Tokyo is a city doesn't really, convey much information. And it gives a reason. So it says comprehensive research on Tokyo should include information on the population, history, economy, landmarks, and cultural significance. So, now we can see that the agent is well aware of his job. So we've tested those two. If you use, so there should be no different solutions, right? For Hosam, the solution shouldn't be different. It's just in the sense of it's harder to evaluate and debug. Right now, we can test the researcher and the agents and the judge individually, but with one agent, you can't really test both functions individually unless you go into the codes, make some breaks, and then test things out like that. But here we can run them in isolation, and we could even use the researcher agents in another project entirely, right? And the judge agents in another project entirely, because the judge agents, for example, seems like something very useful that could be used in several other multi-agent systems, right? So you could easily reuse them by putting them in individual agents. Okay, hope that answers your question. Which solution is better? Multi-agency is better when you're thinking of distributed systems. When you're thinking of scale too, multi-agency is actually better. The problem with multi-agency is, and it's just like software engineering in general, you do not want to overdo it, right? You don't want to, because the more agents you create, the more points of failures you have created, right? So you have more things to work. The more, if you have trying to get 1,000 agents working together, is going to be harder than trying to get 5 agents working together. So you want to find the balancing between how you use multi-agency so you don't create a bottleneck in your application. All right. So next up, in terms of cost, it should just be compute cost, right? They would all burn the same amount of, in terms of tokens, they would all burn the same amount, right? They're irrespective. One is just it's more or less like a question of so to say, monoliths versus microservices. So to say, it's not a direct comparison, right? And you could have your decision making on that same thing. Okay, so moving on to the content builder agents. The content builder agents, that's the creative writer. And what that one does is it just takes the approved research and turns it into a course. Like we said, it's the writing side of the whole agent system. And all we do here is in the agent, the content builder agent.py, we are going to define this agent here. And we are going to make sure we go into our terminal, we leave the judge, go into content builder, go into the agent, and then we paste all of that. So the instructions, it's a content builder, uses the same Gemini preview. It transforms research findings into a structured course, and we give it our prompt. We give it some formatting rules. Start with a main title using a single hash for Markdown or H1. We tell it how to use for section headings. We use bullet points, maintain a professional but engaging tone, right? Ensure the content directly addresses the original request. A very straightforward prompt, nothing to worry about. Now, if you noticed, we did not define how input is passed, right? We didn't talk about how the content builder gets the input. We didn't also talk about how the judge gets the input from the research. And I'll talk about that later, how context is propagated using states. So we'll talk about maintaining states across agents and how that is the glue for communicating between agents. All right, so the orchestrator. So we've built out all three agents, the researcher, the judge, and the writer. Now let's build our orchestrator. So the orchestrator's job, like I said, is just to coordinate the entire workflow and ensures information flows correctly between them. And it uses the A2A protocol, right? So the A2A protocol is basically the protocol agents to communicate with each other. Long story short, it's just the way agents themselves communicate with each other. The same way applications communicates, your front end communicates with your back end using REST or whatnot. Agents communicate with each other using A2A. An alternative will be MCP, right? And it's not a direct comparison because MCP can connect agents to tools, but you get the point. Some protocols, some standard that agents can use to communicate with each other. So it's introduced by Google, and that's the A2A protocol. All right. Okay. So let's get coding. So when we go into the orchestrator itself, it has a lot more code than the others because it's like the center of everything. So it has context of all three. All three agents is orchestrating, and then it transfers, control from one agent to the other and manages the entire workflow itself. That's what the agent does. The orchestrator does, sorry. It's also an agent too. So we're going to copy the code and we're going to inspect it properly before pasting. But we're going to the orchestrator. You go into the agent.py and you want to paste it here. So let's start analyzing the code one by one so we just don't paste anything. So the first thing you want to do is you want to gather the research agents first. So we have the research agents, which is you place that here, which is the researcher URL. Right, no, let's not do that here. This is for the main agents. Let's keep it here. the different agents that we connect to the remote agents. So to an orchestrator, the content builder and judge and researcher, they are all remote agents. They are agents that are living in their own world, right? They don't have to even be on the same machine. By using A2A, the agents will be able to communicate, and the researcher just needs to be aware of them so he knows how to send the communication across board. All right. So the next one is to give me a minute, please. All right, sorry. So the next one is to connect the judge agent. We connected the researcher already. So let's connect the judge agents now. So in your terminal, same kind of line, we copy that. If you look up, you see we already have the remote A2A agent class that has been imported. And we're simply just going to use that here. Right. So we communicate, we specify the description, it gathers information, we specify their URLs, and they're all going to run on different URLs. HTTP 8001 is for the researcher, 8002 for the judge agents. We run them in their separate URLs. So this is how we can simulate a distributed multi-agent system. And then the final one is the content builder. So that's the third agent we're introducing here. So we introduce the third agent here, and same concept, same rules applies. That's it. Give me a minute. All right. Sorry about that. So that's for the agents we need and connecting them together for the orchestrator. The final, or not the final part, the next step is to talk about how we plan to orchestrate across all of them. And this brings me back to the first question that was asked on how to handle timeouts, how do we handle breaking out of the loop generally. And it is the concept of an escalation checker. So the escalation checker does exactly what we need to do. It checks if there is a need to escalate. And if you're within a loop and you escalate, you're breaking out of the loop, right? So that's basically the same concept here. You have an escalation checker. It constantly checks to see it's part of the entire loop system. It works asynchronously as well using generators. I'll explain generators shortly. They are a Python concept. And then when there is a need to escalate, it just escalates upward, it bubbles it up, and then it gets handled by the orchestrator, and the orchestrator knows that's done, and then it gives the results. That's how it works. Right. So what we need to do is just reading the example here. Some agents, not all agents use LLMs. Sometimes you need a simple Python logic. And ADK offers a way to just have an agent that doesn't use an LLM, that just does Python logic. And it's called a base agent. And other kinds of agents, the agents itself, the loop agent, sequential agents, they are built on the base agent. It's the base credential, it's the base agent, literally, right? And that's how it works. So you use the base agent with some custom logic inside a loop agent that I explained, and that's what handles the escalation of events. Thank you. All right. So let's go into so you look into the same orchestrator file, you look for the escalation checker to do placeholder, which is here, the escalation checker, this one. And then you replace all of the code with this function. And this function, you could, let's not delete, let's just put. So what it does is it checks the judge's feedback and escalates the loop if it passed. So remember from the explanation I gave in the first time when I started the discussion is, let me use the single one. I talked about how researcher and judge and the orchestrator are in a loop. And when a result, so when the judge says, oh, we've passed, the escalator then detects that and escalates upward. So that way we break out of the loop. So when we break out of the loop, the next line of action now goes to the writer. So that is how we determine when we are done. Why do we have a class while only one function exists? It's basically, so the function you're talking about, it's we are extending the base agent, right? It's custom logic. So while we could have defined this as one function, remember it's not just an ordinary class, it's not an empty class. We're actually extending the base agents because that's what is needed to plug into the ADK ecosystem we're creating. So I hope that helps. All right. Back to where we were, the escalation checker, and how. So looking at the code, you can now see where state comes in. So there is a context, and the context is going to be passed through all of the agents, and it gets the states. The judge will put his judge feedback. The escalation checker, this is just printing, and this is just if we pass. If it is passed, it escalates. If it's not passed, it escalates. So if you pass, we tell the parent loop agent to stop looping. Why do we use async? So async is not necessarily async, it's an async generator. And a generator is used to provide responses over time, to yield responses with time, even if they are not present at the moment. So it's not like, so the difference between how I look at generators and irregular async await is your async await gives you one response. Once an await happens, you're done. But a generator can yield multiple awaits over time. So you could have, it's more, think of it like you could somewhat demo it like a loop happening somewhere else. And when something is detected, it uses a callback, the way you'd have a callback kind of situation. That's how you do such in Python. With async generators, you're going to generate results asynchronously, so outside of the main context. Right. That's how asynchronous generators work. They are very typical. One of the places where you want to use them are things like in database management, for example, when you're working with Fast API. They typically are used in things like Fast API, like that's when you want to obtain a database connection. And it doesn't just happen once because SQL Alchemy, for example, might be doing some reconnections and retries in the background, and you always want to make sure when a new database connection comes, it is yielded again. It is yielded as you gather it. It also makes sure things can be as lazy as possible, so you don't need to generate something until it is needed. These are just primitives in Python that help you write. Uh, would I say good code? Yes. Let's just work with good code. So yes. So if the judge returns an answer of pass, right? We yield an event. So this is how to bubble up a result, like the way you'd await in a function, and the await just returns the results back up. You await a function and you wait for the result to come. So it bubbles the result back up, which is the author, the name of the author, and then the event action to escalate it upwards. This is how you specify that this particular function is an escalation. So it's an escalation checker, and there is a particular function that you have to implement, and it does this particular thing of escalating upwards. If it did not pass, you just continue the loop. You just continue yielding, and that's it. Nothing more. So this is your escalation checker. It's a little bit. I would say this is arguably the most complex part of the entire system. Putting that final pin that makes sure things are reliable and things are not just running infinitely. Right. So that's the escalation checker, like once again. And that's it for this. Then the next part is the research loop. And the research loop which is the loop that goes to the researcher and gets to the judge. The loop I talked about, the loop agent that gathers the result and escalates it up back to the orchestrator. That's it. So you have your research loop, you have the loop agent, right? You have the name, which is research loop, and you have a description, iteratively searches and all of that. You specify the agents. So we specify the researcher, the judge, and notice how we specify escalation checker. Escalation checker itself is also an agent. So that also replies to why you cannot just use a function. We are actually placing it in the system as an agent, right? Of course, it's an agent that wouldn't do that doesn't need any LLM, which is why it's extending the base agent. We also put the max iterations to 3. So that also addresses the first question. So when we do this 3 times, it yields an answer, and that's all. It stops at that point, and we know the work has failed. So this is it. You copy the research loop, you go into your terminal, you look for the to do on the research loop, and then you paste it there. So that is for this part. And the loop agent is very simple. That's all. That's all it does. The next part is the final pipeline. And I know we've been copying a lot of code, but this is the last code we're copying. So yes. So the last part is we're still in the orchestrator itself. And the orchestrator is now one thing you want to do is you want to define something called a root agent. When you look in the content builder, you notice we call this agent, the content builder agent is just content builder. You call the judge agent is just the judge. And even the researcher is just named researcher. But there is something peculiar about ADK. And when you're working with ADK, ADK looks for something we call a root agent. And the root agent that's one agent that serves as the entry point for the application. So the orchestrator, being the master of everything, is going to declare the root agent. So we'll just come here, copy this. It's a sequential agent, remember? So I said, we have the loop we have the researcher and judge loop, and then it passes the results into the content builder. So it's a sequential agent that takes the loop agent and passes the results to the content builder agent. That's the logic here. So we take it, we copy it, and we paste it as well. So you have your course creation pipeline, a pipeline that researches a topic and then builds a course from it. That's all we need to do here. So we have the application running. You have your local host. Now it's time to run it locally. So deep dive, let's talk about how local development is going to work. So typically in your microservice application, every agent runs in its own server, and that's it. Now, when we deploy, when we deploy to Cloud Run, right, we're going to have 4 different Cloud Run services. So trying to simulate this thing, trying to simulate the services locally is going to be very hard. I mean, it's not the easiest thing, right? But it's also not the hardest thing. You just have to go and run them independently and then make sure the ports are correct and all of that. So the good part about it is this particular repository comes with a script that helps do that. So what it does is sets up the UV-code. It uses UV-code to run processes for the researcher, the judge, and the content builder. And it also passes environment variables for them as well. And we're trying to simulate the exact environment that we're going to put in Cloud Run in the next part of the test. So what you want to do first is you want to run this command. So it uses Perl, and you're specifying a replacement, right? So wherever you have US Central 1, we're going to put global there, and we affect everything in the file. And then we run, the actual file is the run local.sh file. So all things being equal, let me close out this particular one. So I'm still here. Yeah. So I'm going to run the same command, and you have all the agents running using UV So it's creating a Python environment. It builds the orchestrator. It builds the researcher. Orchestrator and researcher have been built. You have the researcher running on 8001, the judge running on 8002. You have all of them running here, and everything is all started, right? So we do not have a problem here. If you do have a problem, you would run into a situation where uh, you would see errors, right? And there are troubleshooting guides here. If you did not set your environment variables job, which is most likely the common cause, all you need to do is just source the .env like we did before. So now let's preview all of these things that we have worked on. So let's see. Let's preview. We're going to preview using the web preview. So we are running on, let me look for that particular line. Yeah. So we're setting up the A2A agent on port 8000. That's the particular one. The fast API agent is running on port 8000. Let's see. I'm going to come. Yeah, you have a local error. This is a cloud SDK missing credentials. Well, so you're okay. So to solve this, you probably want to look at the gcloud there's a particular config, this particular command, the gcloud auth default credentials login, something like that. You can check out that specific command. It's just basically you have to specify the default credentials that gcloud should use when running your application, and that's how you address that particular one. Thank you. So let's test what we've had so far. So I'm going to use the web editor because we're running into shell and we need to preview. And we're running on port 8000. So we're going to run a web preview. And web preview by default looks for port 8080, but we're going to change it to 8000, not 80,000, 8000. And all things being equal, we should actually have an environment. This is our AI course creator. So it sets up the starter application comes with it comes with a front end that's a very simple front end, right? And then it calls the API, ADK API that serves everything using fast API. A very good and this is our AI content course creator, a multi-agent course creator. What we can do is let's test a very simple prompt. Let's create a course about the history of coffee. Now, before we do that, I want to come here and hit enter so many times so we can see, so the logs don't clutter up, right? I'm just going to hit enter so many times so we can see, because when I put this here, you're going to see some logs that talks about how data is being transferred to and from the agents. So let's start building. You click on this, we go back to the logs, you can see there are a lot of things to read here. So it already starts gathering content, it loaded the .env file, it fetches some data, it gets the agent, it successfully resolved it found the researcher agent, and that was good. It's gathering information. Those are all basically the logs. It's still creating because I mean it's not going to be the fastest tool. Look around, but yeah, this is what it does. So the history of coffee, and you have a complete course content creator that does, it even has modules, gathers everything, and then it passes to a content writer. So because we have specifics, you're rest assured you're going to get a very well organized application because each agent is specified for one thing and one thing alone. Yes, it's the same error. You need to run I'm addressing Andreas. Andreas, it's called, let me show you, application defaults credentials gcloud. The particular command you need, this one. When you run this, it will show up, it will pop up in your browser, you select your account, and then you can now run your gcloud set project again, and you should not have the error anymore. All right. So this is a sample demo. It works. You could go ahead and create another course. You could test it locally how you deem fit, right? And that's it. We have our application. This is the point. Do we have reactions in the chats? Oh, no reactions here. Okay. So we've done that already. If you want to test the researchers in isolation, you could call the researcher alone, from within your cloud terminal from the shell here, right? Because you can't access it from outside the shell. We had to use web preview, which Google Cloud sets up some proxy that channels it from the internet. So we're done with that. We have the endpoints to test out the individual agents. Right. So let's go to next. And the next part, which is the final part, is how exactly we deploy to Cloud Run. So deploying to Cloud Run is the simplest part of the whole process because we're just running commands here. We have already seen the application works locally. So moving it to Cloud Run should not be a problem at all. All right, let's get started. So the first thing you want to do is you want to make sure your environment variables are always set. Same process we've always done over and over again. I'm going to shut this down since I have already shown that it works locally. I do not need this anymore, so I can close this. We also don't need any of the editors anymore, so I can even close this, but let's keep this open for now. Let's wait for the server to shut down gracefully. You don't want to rush your server into shutdown mode. Right. Okay, so let's just, yeah, so that's closed out. All right. So the first thing you want to do is you want to make sure you're in the root directory of the project. So you copy the same command, the source.env as well. We're going to run the same command. Sorry, let me just clear my tab. Run the same commands again. So we have all we need. And the next thing you want to do is you want to simply deploy. And deploying is very simple. You want to deploy the researcher first. We deploy the researcher as the first one we're deploying using the command. And it's just gcloud run deploy the researcher. You specify the source file. You specify the region. Allow unauthenticated. Make sure the Cloud Run service is accessible from outside. Then we can just add labels. You can add a label to identify your products. What you should do is you could add a label yourself that helps you identify the project better. So this is dev tutorial equals to production ready one. You could also add another label for service name, and let's call the service name researcher agents or something. We could do a lot of that. Then if you notice, this looks out for environment variables in the terminal. So make sure you run this previous command on sourcing.env. So I'm going to hit enter. And let's see if this works out well. Deploying to Cloud Run might take some time, right? But it's ultimately going to be a good one. So there was no Docker file in the application. So it did not look out for, or is there? Let's see. Yeah, like I said, there's no Docker file in the application. Else, it would have picked up the Docker file and it would have built the image based on that Docker file. Right. So while that is happening, if you want to watch the logs to see how the build is happening, you could click on the link when you see it in yours. I would rather not. While this is happening, let's see if I have any other questions I haven't attended to. So I'm sure Andreas has solved the error. I've answered all questions. Yeah, I think I've answered all questions. So it's looking good. All right. So let's just let's just exercise some patience and see it work out. And patience is truly a virtue this time, because you'd have to do the same thing for the judge and the content builder and also the orchestrator. So it might take a while. But that's
Chukwuemeka, just one small question. What do you think? How much time you need more? Because according to agenda, 5 p.m. Nicolas Malina had session. And what do you think? When we can finish? I think that we close it to summary. So what do you think? Near 10 minutes?
okay. So in terms of minutes, Cloud Run takes, roughly 3 minutes to deploy a service. And we have to deploy 1, 2, 3, 4. We need to deploy 4 services. Oh, actually 5. The actual front end itself, so 5 services. So it might take a while. So what I can do is, we have already shown it works. I already deployed it. Everyone can see it. We have the code lab. Maybe when I am done deploying everything, if we don't have enough time, I could just take questions now and then send in the complete my own Cloud Run application to you. And then you could share the community to let them know, oh, we actually did deploy to Cloud Run successfully using the same code lab, right? So we don't have to do everything right here. And that was the essence of running locally. I already showed it runs locally. We all got to that point already. It's now a deployment thing. Yeah. Okay, so Martina's error is invalid build request. 403 storage. So your problem, so either of the two things, one, either your API for cloud build is not enabled, or you're using a wrong project in the terminal. Those are the two things, either of the two. Either you've enabled you've enabled cloud build, you've not enabled cloud build on the project, or you have enabled cloud build, but you're not using the right project. So you want to confirm that. You want to confirm that. Or you also want to confirm that the user in your terminal is the actual user, is the right email address that is attached to the cloud credits. Okay, so how can we force an agent on a certain port? Yeah, it's all specified. If you look at run local, the run local file itself, you can see how we specify the ports. 8001, 8002. It's all using UVCon, right? So UVCon, you can just specify the port and the host. So you can play around with it however you want to. It doesn't, there's no tying down to the host. So this is the first one. So I'm waiting for more questions. Whenever my time is up, you can just let me know, but I'm just going to keep deploying and looking out for more questions. Okay. Okay, so we have a review. Somebody said it works. Ishara said it works properly, and yeah, you're welcome. So yeah, so we know it works now. I mean, we have more confirmation. So I look forward to seeing, make your posts, make your AI content creator, generate your content, and send it to me. Okay. KP, would you ever consider having two orchestrator types? Well, typically, many a times, most systems only need one orchestrator. And it's not just even agents in this, it's not just agents. When you look at tools like Kubernetes, for example, there's just one control plane. It might be distributed across several nodes, but it is really just one control plane. One control plane that then manages several worker nodes. So when it comes to this master slave architecture, many a times there's just one master. And there hasn't been another need for an extra master. The only time I think you might need another orchestrator is in the sense of parallelization. So you create a new instance of the orchestrator. So let's say you want to upscale, so you create more instances of your orchestrator agents. That's the only edge case I see. But other than that, you don't need to run two different orchestrator. you can run one instance of an orchestrator multiple times, so it does the same thing. That's probably that. I hope that answers your question. So yes, you're welcome. So this is our agent. It runs perfectly. And what I would love to see us do is deploy your app to Cloud Run, make a post about it anyway, and tag me. That way I get to know, okay, you've done the work and it works. It gladdens me, it gladdens the entire community to see us building with AI. So yes. That being said, in summary, that's pretty much all. I've shown how you can use the two different loops, sequential and loop agents. Deploy to Cloud Run. Andreas, so step 11 talks about deploying to Cloud Run, and it has the commands to do all of that. Sorry, deploy to Cloud Run has all of that. So you could do all of this using G Cloud Run. You could run that from your local laptop, and it does everything. Yeah. So that's pretty much it. In summary, we've talked about how we can use sequential agents and the loop agents. The eight-way protocol is particularly very important and very useful. And this is just content creation for course. But think about local copy works. But think about the possibilities you can achieve by having agents working together. Fun fact, tools like Claude Code at the heart of it all actually use a loop agent to do everything. So you have the agent that writes the code, the other one that judges, the orchestrator that handles everything. And there's actually a loop agent. They don't use ADK, of course, but the same concept is what is taken there. So you could understand this is how to orchestrate agents. And it's a very beautiful one to use. It's something I highly recommend. Try it out with other examples. Work on an agent that probably takes in user requests, customer satisfaction or something, or one that analyzes the logs of your company and judges over and over in a loop until you get an accurate response, an accurate reason for for an issue in your company logs, for example. So yeah, these are sample use cases, and thank you. Thank you all.